Okay, let's see our problem. Chris Wu, a career counselor, claims the average number of years of schooling for medical doctor is 17.8 years. A sample of 16 medical doctors had a mean of 16.5 years and a standard deviation of 1.5 years. Do you think Chris' claim is acceptable? First of all, I like to emphasize that the standard deviation or the variance of the population is not known, and the sample size is pretty small, 16. So we need to use t-test instead of z-test. We are using t-test because the main reason is the variance or standard deviation. Remember, variance is the square of standard deviation, is not known for the population, so we need to use t-test. As you can see, the formula is very similar. Instead of standard deviation for population, we use standard deviation for sample. Now, if you look at this problem once again, you can see it's two-tailed. We are looking if there is a difference between the Chris claim and the sample. So H0 mu equals 17.8 and H1 mu is not equal 17.8. The next step is to find out the critical values. Now, instead of looking for z table or the z function, we need to use another Excel function. Let me bring the graphic first. We need to use the Excel function. Now this time the function is t.inv.2t. t.inv.2t. Since this is two-tailed, actually this 2t stands for two-tailed. t.inv.2t. So the probability which is the level of significance 0.05, level of significance 0.05, and the sample size, since the sample size is 16, degree of freedom would be 16 minus 1, 15, so which is B10. So I enter B5 and B10 to find out the T critical value, and this number is 2.13. Since this is two-tailed, that should be then minus 2.13 and plus 2.13. So you can notice here I just have a minus sign in front of the function. Minus t.inv.2t, because on the left side it should be a minus. Now any number between minus 2.13 and plus 2.13 would be H0 accepted. Any number beyond these points, any number for t statistics or t-test beyond these points will show us H1 should be accepted. Now if I look to B11, which has the formula for t-test, which is x bar minus mu. Now if you look, x bar is sample mean, which is B7, minus mu population mean, which is B4, divided by standard deviation of the sample, which is 1.5, B8, divided by SQRT, square root of sample size, which is B6. So once I calculate this, I found t-test statistics minus 3.46, and this is outside the limit. It's not between these two numbers, so I would say H1 accept, which means we cannot accept Chris' claim. Chris' claim is not acceptable because 16.5 is significantly different what Chris says.